Welcome to the Deep Dive. Today, we're digging into something pretty important as we use these large language models more often. How do we actually make sure they're giving us, the right facts?
Right. It's a real issue. They can sound so confident, but sometimes...
Sometimes they just invent things, especially for like niche topics or really recent news.
Exactly. And that's where our source material comes in today. It looks at this approach called Retrieval-Augmented Generation, RAG for short.
RG.
Okay.
Okay, so the basic idea is don't just rely on the model's memory.
Precisely. Give it a way to look things up, fetch relevant info from outside knowledge sources to build its answer. Boosts that factual accuracy.
Okay, that makes sense. But I've noticed a lot of current RAG systems seem a bit, well, one-track-minded.
How so?
They mostly seem to grab text, right?
Yeah.
From maybe one big database.
It's often the case, yeah.
But real questions.
Yeah.
Sometimes the best answer isn't text. You might need a picture or, I don't know, see how something works in a video.
And that's the perfect lead-in to UniversalRAG, which is what we're really focusing on.
UniversalRAG, got it.
The sources present this as a new way to get around this exact limitations you mentioned.
So it can handle different types of information.
Yes. Text, images, video,
No.
pulling from various sources, and crucially at different levels of detail, too.
Okay, interesting. So it's not just throwing everything into one massive, messy knowledge pool then. How does it manage that complexity?
That's really the core innovation here. The researchers found that trying to force, text, images, and video data into a single unified way of understanding, it actually creates problems.
Problems, like what?
They call it the modality gap. It's a key concept in the paper.
Modality gap. Okay.
Think of it like, even if you teach an AI that a picture of a cat and the word cat are related, the underlying computer representation of pixels is just fundamentally different from the representation of letters.
I see. So they don't truly mix well.
Exactly. Even with alignment efforts, the data tends to cluster by its type text with text, images with images, rather than purely by semantic meaning. One of the figures shows this quite clearly.
And that gap causes issues for retrieval.
Big issues. It can lead to biased results if your question is mostly text.
The system might just pull back text answers, even if a great image or video clip exists.
Precisely. It defaults to the format it's most comfortable with, or the one that looks closest in that flawed, unified space.
So UniversalRAG's solution is don't unify.
Basically, yes. Instead of one big space, it maintains separate collections, separate corpora for each modality. Text knowledge lives here, image knowledge over there, video knowledge somewhere else.
Okay. Distinct libraries of information.
Right. And each library has its own specialized way of indexing and understanding the information inside it.
And connecting these libraries.
Yeah.
That's the router job.
You got it. The router is like the intelligent traffic controller. It looks at the user's question first, analyzes it, and then it dynamically decides which specific modalities library is the best place to search for an answer.
So it avoids comparing apples and oranges, essentially.
Yeah.
Text similarity scores versus image similarity scores.
Exactly. No direct, potentially misleading cross-modal comparisons at that stage. And as a bonus, the researchers say this makes it easier to add, say, audio or 3D model support later on. It's more modular.
Right. Makes sense. Now, you mentioned levels of detail earlier. UniversalRAG doesn't just pick the type of info, but also the amount.
Yes, and that's another really crucial layer, because granularity matters a lot.
Granularity, like how fine-grained the information is.
Exactly. Think about text.
Yeah.
Sometimes you just need one specific fact from a single paragraph.
Like, what's the capital of France?
Right. But other times, you might be asking something more complex, like analyze the causes of the French Revolution. You need broader context.
You need maybe a whole document or several.
Precisely. Same for video. A quick show me the goal might need a 5-second clip, but explain the process of might require a longer segment.
So UniversalRAG is smart about this too.
It organizes each modality corpus into different granularity levels. Text can be paragraphs or documents. Video can be short clips or entire videos.
And images, are they treated differently?
Images are often considered inherently fine-grained, representing a single snapshot of information, so they usually just have the one level.
So the router's decision is quite complex then. It's choosing modality and granularity.
That's right. The possible routing decisions it makes include things like none if the LLM might already know the answer internally,
Okay.
or paragraph, document, image, clip, or video. It picks a best fit.
Wow. How on earth does it learn to make that choice? The sources mentioned a couple of ways.
Yeah, they explored two main paths for building this router, a training-free one and a trained one.
Training free sounds easy. How does
Yeah.
that work?
It's quite clever, actually. It leverages the power of a very capable existing LLM, like GPT-4o, in their tests.
Okay.
They basically give this powerful model a set of instructions, a prompt with examples, showing it different kinds of questions and explaining which type and granularity of retrieval would be best.
So you're using the LLM's own reasoning ability to figure out how to best help an LLM answer a question.
Exactly. It uses its broad understanding of language and information types to classify the query without needing specific router training itself. There's a figure showing the prompt they use.
Okay, that's neat. And the trained router.
That's more traditional in a sense. They took smaller, more focused models like Distilbert or T5 Large and specifically trained them just for this routing task.
Train them on what, though? How do you create that training data?
They were smart about it. They took existing question-answering data sets where they generally knew the characteristics of the questions and answers.
So if a data set like, say, WebQA often needs images.
They'd label questions from that data set as ideally needing image retrieval. If another data set like Hotpot QA often requires combining info from multiple places.
They might label those as needing document retrieval for more context.
Exactly. They created a labeled data set reflecting these ideal retrieval strategies and trained the router models on that.
Got it. One leverages existing intelligence, the other trains specific expertise.
Well put.
So the big question, does this whole UniversalRAG setup actually work better in practice? What did the results show?
They showed some really positive results. Yeah, they tested it across, I think, 8 different benchmarks covering text, images, video questions, a real mix.
Yeah.
And UniversalRAG consistently came out on top compared to baselines. Baselines meaning systems using only one modality, or that unified approach that suffers from the modality gap.
So beating the unified approach is direct proof that tackling the modality gap this way helps.
Yes, the improvement over the unified baseline was significant, which really validates their modality-aware routing idea.
What about the two router types? Trained versus training free?
Generally, the trained routers had a slight edge in performance.
Which makes sense. They were purpose-built.
Right. But interestingly, the training-free GPT-4o router wasn't far behind at all. It still beat many of the standard baseline methods quite handily.
So even just prompting a powerful model works surprisingly well.
It does. It shows the potential of that zero-shot routing approach, which is quite promising. Less need for custom training data.
The sources also have tables looking at router accuracy itself, right?
Yeah.
How well it picked the right strategy.
And you can see a clear link. Better router accuracy, correctly identifying the need for an image or a document or a clip led directly to better final answer quality.
So getting that initial retrieval step right is absolutely key.
It really is. Garbage in, garbage out. Even with a smart LLM doing the final synthesis, the router's job is critical.
And the granularity piece, choosing paragraphs versus documents, clips versus videos, did that specific capability show clear benefits?
Yes, definitely. Table 3 in the source material breaks this down. On datasets like Hotpot QA, where you need context from multiple text passages.
Right, the multi-hop question.
Being able to retrieve whole documents instead of just isolated paragraphs made a big difference. Similarly, for video QA on LV Bench, choosing the right clip was better than dumping the whole video.
So tailoring the amount of information is just as important as the type.
Absolutely. Too little context, the model can't answer. Too much irrelevant stuff, it might get confused or miss the key detail.
Okay, so it works well on the tests they designed using known data sets. But what about new, unexpected questions? How does it generalize?
That's a great question, and they did test that. They evaluated it on out-of-domain datasets, types of questions the trained routers hadn't specifically seen during their training.
And how did that go?
Here's where it gets really interesting. The training-free router, GPT-4o,
Yeah.
it generalized remarkably well. In some cases, its accuracy on the new datasets was even slightly better than on the ones it had seen examples for via the prompt.
Wow. So its general reasoning ability really shone through.
It seems so. It suggests a more fundamental understanding of query types, perhaps.
And the trained routers.
They sometimes struggled a bit more on the completely new data.
Overfitting, maybe?
Yeah.
Too dune to the training examples?
That's the likely explanation. They learned the patterns in the training data very well, but that made them slightly less flexible when faced with something different.
Which led them to suggest an ensemble, combining them.
Exactly. Maybe use the trained router for speed and efficiency on known tasks, but fall back on the training-free one's general intelligence for unusual queries. Get the best of both worlds.
Interesting. And does the sheer size of the AI models matter here? Like bigger routers or bigger final answer models?
Yes, the sources touch on that. They found that larger router models, like T5 large compared to Distilbert, generally made more accurate routing decisions.
More parameters, better choices.
It seems that way. And also, using a larger, more capable vision language model for the final generation step, the part that actually writes the answer using the retrieved info, also improved the overall performance of UniversalRAG. Figure 5 shows this trend.
So the framework benefits from general improvements in AI model scale.
Right. It suggests that the approach itself is scalable and will likely get even better as the underlying models improve.
The specific examples they showed were really helpful too, I thought. Like the one about balloon colors.
Oh, yeah, the WebQA example. The question needed the color of balloons in an image.
And a text-only RAG would fail.
Completely. Video only might too, if the balloons weren't in motion. UniversalRAG correctly identified image as the needed modality and got the answer.
Then there was that hotpot QA, one needing document-level context.
Right. A complex question requiring connecting facts from different parts of a larger story. Retrieving just paragraphs wasn't enough. UniversalRAG chose document.
And the video clip won for LV Bench.
Asking about a specific action or moment in a video. Retrieving the whole, potentially long video is inefficient and might confuse the generator. UniversalRAG correctly routed to clip, pulling just the relevant segment.
Those really illustrate the benefits of being modality and granularity aware.
Definitely brings the concepts to life.
Okay, so wrapping this up then. The core message seems to be that UniversalRAG offers a smarter, more flexible way for these LLMs to use external knowledge.
I think that's a fair summary. By intelligently selecting not just the right type of information, text, image, video, but also the right level of detail,
Paragraph, document, clip.
it can draw on a much richer, more diverse set of knowledge sources. And the result seems to be more accurate, more comprehensive answers.
And it directly tackles that modality gap problem, avoiding the pitfalls of trying to force everything into one mold. Plus, thinking about granularity is key.
Both are crucial steps forward, absolutely. It moves us towards AI that's more adaptable, more reliable, and better able to actually leverage the world's information, which comes in so many formats.
It really does represent a significant step, doesn't it, towards AI that can tap into all this varied knowledge more effectively.
I believe so.
And it makes you think, what does this mean for the future? If AI gets really good at navigating text, images, video, maybe audio, maybe other things, how does that change how you, the listener, might interact with it?
Yeah, what new kinds of questions could you ask? How might it help us learn or understand really complex topics that span different types of media?
Could it synthesize information in entirely new ways? It opens up some fascinating possibilities.
It certainly provokes thought about how we structure knowledge and how AI learns to access it, that intelligent retrieval across formats. It could be transformative.
Really fascinating work. If you want to get into the weeds, the technical details, and all the charts, you can check out the paper or the project page. It's at universalrag.github.io.
Definitely worth a look if you're interested in the nitty-gritty.
This definitely feels like a space to watch. How AI learns to find the right information in the right form is going to be critical. Thanks for joining us for this deep dive.